Atoms are considered with the building blocks of matter, and we believe that atoms make up molecules, molecules made up objects. Now, for a long time, people considered atoms as fundamental particle, like it was an indivisible, complete single particle making up everything. There was nothing uh, in an atom. Atom was considered one single small complete thing. But later we came to do some experiments and we discovered that no, atoms are not uh, just one thing. Okay, now then there came a time that we started to believe that atom is not a complete thing. It is made up of uh, smaller particles. Some people do experiments like Rutherford. He passed some alpha particles and he found out that when alpha particles were passing through the gold foil, which they should either not be able to pass through, or if they pass through, they should be tear the gold foil apart. Then they can easily make their way. And alpha particles were capable of, theoretically capable of doing that, but they did not. When they were fired towards the gold foil, they they passed through without damaging the gold foil. This was revolutionary. This was something that made a big paradigm shift. And instead of considering atom as things which are evenly distributed, we now have a very modern model of atom. We know that atom has a uh, center known as nucleus. All the positive charges over there, and electrons are in the shells around the nucleus. And nucleus is a very small part of an atom. It is in diameter. It is a million times smaller than an atom. And when we go to the volume, it it becomes million to the power 3. That is how small a nucleus is as compared to an atom. And how do we know that? Because when alpha particles were fired towards the gold foil, almost 99%, more than 99%, they just passed straight through with deviations less than 90 degrees, less than 10 degrees. Then 0.9% they deviated angles between 10 and 90 degree, and there was a very small percentage, almost one out of every 8,000 or 10,000, which makes about 0.1, 0.01%. They came back towards the source side, like they were bounced back from something. The question is, what can bounce back an alpha particle? Alpha particle is a small bullet kind of object. It should not be stopped by something. It can only be stopped by something if it meets something heavier than it, far more heavier than that. For example, if you consider uh, uh, you're holding a tennis ball in your hand and you hit an empty can of any soft drink with that ball, you will find out when the ball hits the can, it will make the can fall over. It will just make the can move in the direction of the ball. But if you hit the same tennis ball to an anvil or something very heavy, what happens is the ball bounces back. The question is, if alpha particles are bouncing back, it means they have encountered something very, very heavy. Now, not only that thing is very, very heavy, it is a very small thing as well. How can I say it is very small? Answer is because very few alpha particles came back. Most passed straight through. So it means that they did not encounter anything on their way. That means most of an atom is empty space. It is just vacant over there. There's nothing, space within an atom. Now, this is how we came to know that atom is not a whole thing. It is something which is made up of protons, neutrons, electrons, and protons and neutrons are inside the nucleus, or actually not, we should not say inside the nucleus. They are the nucleus, protons and neutrons. And there starts the time when we started to believe that electron, proton, neutron are the smallest particles. Now, instead of atom, we started to consider electron, proton, neutron as fundamental small particles. And in 1950s, there came a time when scientists got a toy they started to play with, which was known as a particle accelerator in CERN. So what they did is they accelerated different particles, electrons, protons, neutrons, and then they bombarded them on a metal target and broke them. And when they broke them, they felt that there are number of particles coming out of those particles. Now, here is the thing. No matter how fast they moved and how hard they hit an electron never break into anything smaller. So they started to believe that electron is a fundamental particle. But not the story with proton and neutron. When they accelerated proton and neutron and they hit them on a metal target, they found that no, proton splits into smaller particles. Same goes for neutron. So that means proton and neutrons are not made of not single particles. They're made up of smaller particles. Now, when scientists continued, they found that there are so many particles that they had to classify them. When they were breaking protons and neutrons, they came to know many quarks. These are particles which have mass as well as charge. They have mass nature and charge nature. For example, up quarks and down quarks, they make 1/3 of the mass of any proton or neutron, and they contribute in the charge as well. So similarly, the one family of the particle, these are the particles which are considered to be the fundamental particles. Now, quarks, second family is leptons, and third family is boson. Now, the list is very long. Excuse me. The list is very long for quarks, sorry, not for quarks, leptons and bosons, but we are just considering the things that are in our syllabus. Every particle has an antiparticle as well. An antiparticle is a particle that has same mass but charge. Two particles are called antiparticles if they have same mass but opposite charge. Now, there's one lepton that we already know, electron. Then anti-electron, an antiparticle of electron, it has same charge as electron, same mass as electron, same magnitude of charge as electron, but the sign of charge is opposite. It is a kind of positive electron known as positron. Electron neutrino and electron antineutrino. Now, same goes for, like, one boson is famous, known as photon. We know photon, the discrete electromagnetic particle. And we only need to know that. W plus boson and W minus bosons, they are responsible for the strong nuclear forces and weak nuclear forces. We'll be discussing them later. So there are three families of the particles which are fundamental particles and they make up other particles. Now, quarks. Mm, here we go. Particles and their antiparticles. For example, there's an up quark. You can see in the left side we have charged particles, and on the right hand side we have their antiparticles. Now, first one is an up quark. It has a mass 1/3 of a proton or neutron. It has a charge 2/3 of elementary charge, +2/3 of elementary charge. Electron has a same mass as like 1840 electrons have same mass as one proton. So electron is not a lot of mass, but it has a charge of -1. Similarly, positron, which is the antiparticle of electron, has the same mass, 1/1840 of mass of proton, but it has a charge of plus elementary charge, +1. Neutrino and antineutrino, they have zero mass, zero charge. Now, these are the ones that you need to know. Okay. Up quark will have an anti-up quark. Down quark will have anti-down quark. Sometimes what happens is when somebody asks you what is the anti-particle for up quark, so we think that down quark is an anti-particle for up quark. No, down quark is a different quark with its own anti-quark. Up quark is a different quark with its own anti-quark. Now, what will happen if a particle meets its own antiparticle? As soon as a particle gets together with its own antiparticle, annihilation takes place. The matter completely disappears and it converts itself into energy with two equal photons. We will be discussing them in A2 in detail to find out how to find the frequency of the photon, energy of the photon, wavelength of the photon. But right now, this is enough that whenever a particle meets its antiparticle, annihilation takes place. Now, particles that are made up of quarks. A muon is a combination of a quark and an anti-quark. So if there is a particle that is made up of two quarks, one quark, one anti-quark, that will be known as muon. What is a hadron? Hadron is any particle that is composed of two or more quarks. Any particle that is made up of two or more quarks is known as hadron. What is baryon? Baryon is a particle composed of exactly three quarks. Anything that is made up of three quarks will be known as baryon. For example, there are two baryons that we already know, proton and neutron. A proton is made up of two up quarks and a down quark. And a neutron is made up of one up quark and two down quarks. If somebody asks you the combination of like how protons are made of, or what protons are made of, or what neutrons are made of, so you know a proton is made of two up quarks and one down quark, and neutron is made of one up and two down. And remember, when we write something uh, like this. This is how do we write something. The top value that is on the left top shoulder of a variable or a symbol, that is atomic mass, number of protons and number of neutrons. It is called atomic mass, mass number, nucleon number. Okay, its unit will be U, and each U is 1.66 into 10 to the power minus 27 kg. X will be the symbol of the atom in the periodic table, and Z, which is in the left bottom of the object or the sorry symbol, this number is number of protons. It is also known as charge number, atomic number. Okay. So when we write proton like this, if we write proton like this, it means mass of proton is 1U. Charge on proton is 1E. So the upper number is always mass, the low number is always charge. Just keep that in your mind. Now, if we have an up quark, here's a detail of proton. Look, there are two up quarks, one down quark. Each up quark has a charge of 2/3. Look, each up quark has charge of 2/3, and the down quark has a charge of minus 1.1/3. If we add these three values, 2/3 plus 2/3 plus minus 1/3, what do we get? So 2/3 plus 2/3 minus 1/3. So we add them. If you use your calculators, do 2/3 plus 2/3 plus minus 1/3, you will get 1. So that's why the charge on proton is 1. 1/3 plus 1/3 plus 1/3. We add the masses and we get the mass of the proton. This is why mass of proton is 1, because it is made up of 2 up quarks and 1 down quark. What about neutron? Neutron is made up of 1 up and 2 down quarks. Look, the charges are plus 2/3 minus 1/3 minus 1/3. So it will be 2/3 plus minus 1/3 plus minus 1/3. So what do we get? 2/3 plus minus 1/3 minus 1/3 equals to 0. That's why the charge on neutron is 0. It is not because neutron does not have any charge particle. It is because it has an equal amount of positive and negative charge. So it is neutral. And what about mass? 1/3 plus 1/3 plus 1/3. That makes the mass of neutron same as mass of proton, because proton is made up of 3 quarks, and neutron is also made up of 3 quarks. So they both are baryons because they are made up of 3 quarks, and they're also hadrons because they're made up of quarks. Okay, now, whenever a nucleus becomes unstable, it wants to gain stability, it is running short of the binding energy, or it does not have enough energy. It is known as unstable nucleus. So to gain stability, what a nucleus does is it removes some of its mass. Like it emits a combination of two protons and two neutrons. And when that combination is emitted, rest of the nucleus becomes more stable. But remember, when any substance loses two protons and two neutrons, it will not stay the same substance. Because when two protons are removed, it is not like something will become another isotope of something. It is change of protons. It means the element changes. For example, a uranium emits a alpha particle. It emits two protons and two neutrons, and it does not stay uranium anymore. It becomes radon. Radon emits another alpha particle and becomes iridium. So uh, element changes when any particle emits alpha particle. Okay. Now, alpha particle is made up of two protons and two neutrons, very much like nucleus of helium, which is also made up of two protons and two neutrons. Mass is 4U, where U stands for atomic mass unit, which has a value of 1.6 into 10 to power minus 27 kgs. If you want to convert the mass into kgs, you can. Charge will be 2E because of the presence of two protons over there. This is highly ionizing, super slow as compared to the other particles which move. Least penetration ability can be stopped by a thick sheet of paper or some centimeters of air. When they leave a nucleus, the new nucleus has a mass which is 4 less and charge which is 2 less than the mother nucleus. So this is how we write this equation. There was an element X, it emitted an alpha particle, so it did not remain X. It converted into some other nucleus, Y. That Y will have a mass which is 4 less and charge which is 2 less. And this is gamma photon with high frequency. Any questions? Nope. Okay. Okay, that was the case when the whole nucleus becomes unstable. What if any nucleon become unstable? For example, a proton thinks that I should not be a proton. I was supposed to be a neutron. Or a neutron thinks that I am not supposed to be a neutron. I should be a proton. So when these kind of changes happen in the nucleus, a proton converts to a neutron or neutron converts to a proton, a beta particle is released. So it is not the whole nucleus which is becoming unstable. It is this, it is a nucleon, not the nucleus, but nucleon. Now, when a proton is converting into neutron, it is not like the whole thing has to change. If you focus, you have up, and down quark in a proton and up, down quark in a neutron. So actually only an up quark is converting into down quark or a down quark is converting into up quark. If a proton converts to a neutron, up quark converts to a down quark. If a neutron converts to a proton, a down quark converts into an up quark. How does this happen? And what are the results of this happening to the nucleus? This is what we'll be discussing in the next class. We'll resume from the same point in the next class. This is it for today.
Love.
Allah Hafiz. Mubashir can.
Love.
Okay. Allah.